All right, good day, guys. Welcome to this class. And in this class, we are going to be talking about a new topic called elasticity. We have been familiar with the word elasticity. Now we are going to be talking about the physics of elasticity, and we are going to be going straight to the point, right? Now, first of all, let's define the word elasticity in physics. Elasticity, write this down, it is very important. Elasticity is the property of a solid that when it is being distorted, it regains its original shape. Remember this and write it down. Elasticity is the property of a solid that when it is being distorted means when it is turned into another form or when it's being deformed, this property will regain its original shape. What do I mean? For example, let me take an elastic material, this rubber. You can see now the original length here now is this point, right? If I mark it, I'll have something like this, right? Now, the property of this rubber to extend more than its original length when an external force is added to it. Are you getting it? When an external force is applied to the rubber, is called elasticity. And when I remove that force, it comes back to its original length. When I apply the force, it is elongated. Now you see that the property of those material is called what? Elasticity. Are you getting it? Now there is a law that we are going to define very carefully, and that law is called Hooke's law. Hooke's law. Make sure you write that definition down, and let's talk about Hooke's law. Hooke's law. Now let me take that rubber and demonstrate something. We see that the original length is from this point to this point, right? So it's like this from point A to point B. Now if I apply an external force to this rubber, what will happen? There will be an elongation, right? Now discover something. This rubber is extending depending on the amount of force I have applied to it. So if I apply a smaller force to this rubber, it will extend a little. If I apply more force to the rubber, it will extend more. If I apply more and more force to it, it will extend more. What does that tell you? It means that the more the force you apply, the more the length. True or false? So you discover that the rubber original length was what? And then it now has an extension. An extension. Are you getting it? It now has an extension. We can use the dotted line of E. What does it tell you? It means that the more the force, the more the extension. Now let us define Hooke's law. Hooke's law of elasticity states that provided that the elastic limit of an elastic material is not exceeded, the force applied, are you getting it, is directly proportional to the extension. Provided that the elastic limit of an elastic material is not exceeded, the force F applied to the material is directly proportional to the extension. What does that mean? It means that the more I apply the force, the more the extension. The less I apply the force, the lesser the extension. Right? Now, listen very carefully. Listen very carefully. I can also redefine Hooke's law like as the force on an elastic material, are you getting it, is directly proportional to the extension, provided that the elastic limit is not exceeded. The word extension can also be replaced with the word strain. You can also say provided that the elastic limit of an elastic material is not exceeded, the force applied is directly proportional to the strain. Are you getting it? Now, let us go further. Let us talk about elastic limit. From that definition, it said provided that the elastic limit. For example, do you know that there is a limit I will stretch this rubber to, then the rubber will cut off? That point where you stretch it to is called the elastic limit. But provided that the rubber did not cut off, the force you apply is directly proportional to the extension, right? All right. Now let's continue our derivation. Let's continue. From here now, we see that this is a direct variation, right? Because directly proportional is this symbol. Now we cannot solve with this symbol. True or false? What we do is that we have to change it into an equality sign, and we know that from direct variation in mathematics, to change a proportionality sign to an equality sign, there is a constant that must be added, and in this case it becomes what? F equal to KE, right? We have succeeded in changing this proportionality sign to an equality sign. Now listen very carefully. What is K? K is called elastic constant. K is called what? The elastic constant. What is F? We all know that F is the force applied, right? F is the force applied. What of E? E is called what? The extension. E is called the extension. Now listen very carefully. We are not going to be solving problem in this class. We are just going to be talking about the explanation and the concept behind elasticity. We are not going to be solving problem. Now in the next class, we are going to be using these formulas. Now in exam models like JAMB, WAEC, POSUME and JEE, most times there is something you need to know. If this F is equal to KE, right, it therefore means that K is equal to what? F all over E. True or false? Now, what is K? K means constant. Every material has their own elastic constant. Every material has their own what? Elastic constant. Are you getting it? Now, for example, if for a given material, are you getting it? I apply the force F1. Are you getting it? And it gives me an extension of E1. Then I increase my force to what? F2. And it gives me another extension of E2, which means that I can represent it like this. F1 over E1 is equal to F2 over E2. Are you getting it? Because the K will not change, right? This is another formula to note. So formula 1 to note. This is the first formula to note. Write it down. This is the second formula to note. Any problem? Now, there is something. I will give you time. I will give you time to learn this, because we are going to be hitting the main point. That's our aim. We are hitting the main point. Now, after this, since you are done with this, let us just take a simple question. But in our next class, we will be doing more of calculations. This is just to explain the concept involved in elasticity. Let's say a force. Calculate the force required to extend a string, are you getting it, of elastic constant 50, are you getting it, 50 Newton per meter by 20, let's say 20 meters, because we don't have time. We'll be going to deeper calculations in the next class. So from this, what will you observe? When you are given a problem in physics, what you do is to write out first the parameters. Now, calculate the force. The first thing you are required to do, you will write out is what? Force, F. And since they say calculate the force, it means that F is what? Unknown. You go further. Required to extend a string of elastic constant. Now, what is the symbol for elastic constant? K, right? K. To be equal to what? 50 Newton per meter. Oh, sorry, I forgot to give you the unit of elastic constant. The unit of elastic constant, the unit of K, that is elastic constant, is what? Newton per meter. So 50 Newton per meter by 20 meter. It therefore means from here the extension is what? 20 meter. So what do? You look for the formula that relates F, K, and E together. And that formula we have just said is what? F is equal to KE. True or false? This is a simple question that requires what? Direct substitution. So it means that F, K now is what? 50 equal to 50 times E is what? 20, right? 50 times 20 is what? 5 times 2 is 10. And just add it 0. So that becomes 1000 Newton. Simple, right? All right. So since that is that, let's go into the next section of the class, which is called energy stored in an elastic material. The energy stored in an elastic material. The energy stored, we are still doing physics. Energy stored in an elastic material. You should know that all elastic material has an energy, and that type of energy is called potential energy. Why is it called potential energy? Because it has the ability to do something, but it cannot do it until you apply a force to it. So this rubber has a potential energy, and that energy is what we are going to be checking out. Now listen very carefully. We are going to be deriving this energy. Do you know a catapult can throw a stone? The ability for that catapult to throw a stone along a distance, it means that the catapult has an energy, right? The catapult string has an energy. So let us take an example from this string. Now imagine this is a catapult, and this place there is a stone here. Do you know that the more I extend it, the more force it will require for me to extend the catapult? Right? Now, if I want to extend it again, the force I started with cannot be the force I will end it with. For example, I started it from here to this point. Do you know that if I start from point A, let this be the length, right? If I start from here with F1, and I extend it, this becomes the extension E to a point F2. Do you know that the force I will use to start drawing the catapult from this point will not be the same with the force I will use it to extend it to this point? This one will be greater, right? So in that case, what do? We take the average force, because are we to use this one or to use this one? We take the average force. And average means what? Sum of quantities, right? That's average in mathematics. Sum of quantities, that's F2 plus F1 all over what? The numbers of quantity. And the number of quantity is what? 2. Are you getting it? Are you getting it? Alright. Now, let's say F1 and F2, since we can't, it's hard to really know F1 and F2, let us just make F1 and F2 equal to F. So let's F1 and F2 be equal to what? F. Are you getting it? So that means that let F1 plus F2 be equal to F. So that means that everything here can be rewritten as, say, F over 2, since all of them are forces, to make things simple. So it therefore means that the force involved in this extension is what? F over 2. Are you getting it? Now, what is energy? If you go back to our video, we said that energy is equivalent to work. Are you getting it? So if you want to derive energy, we start from the concept of work. And what is work? Work is what? Force times what? Distance. True or false? Now the force involved here now is what? F over 2. And the distance involved here now is called what? Extension. That is E. Are you getting it? So therefore means that the energy stored in an elastic material is F over 2 times E. And F over 2 times E is the same thing as what? Same F over 2E. That is formula 1. Or you can simplify it. You know F over 2 is the same thing as saying 1 all over 2 Fe, right? Factoring out these two. So the first formula to note here under work done in elastic material is 1 all over 2 Fe. Make sure you write this down. This is very important. The derivation, if you like, but in most exams, this is what you need. 1 all over 2 Fe. Now, let us add another formula to it. Let us add another formula to it. Remember from Hooke's law. Hooke's law says that what? F is equal to what? Ke. True or false? Now, if F is equal to Ke, now remember from this formula we have 1 all over 2 Fe, right? Now, what if we replace this F? Since F and Ke are equal, what if we replace this F with Ke? What do we have? We have what? 1 all over 2. Instead of me writing this F now, I want to generate another formula that doesn't have F. Now, I will put Ke here. This becomes Ke, right? In place of F. Then my E still remains E. Right? So, what does it mean? E times E is what? E squared. True or false? Then we have our K, then we have 1 all over 2. It therefore means that the second formula for elastic energy is what? 1 all over 2 Ke squared. So the first formula for elastic energy or elastic work is 1 all over 2 Fe or 1 all over 2 Ke squared. Make sure you write those things down. It is very important. When we start solving questions, other JAMB, Neco, WAEC, JEE, and other O-level exam, you will see the effectiveness and the importance of those formulas. Alright. Now, the next topic we will talk about is called Young modulus. I told you we will finish everything about elasticity in this video. Make sure you write those things down. The next one we'll talk about now is called Young modulus. Now, what is Young modulus? Young modulus, the symbol for Young modulus is E. Young modulus is the ratio of elastic stress, listen very carefully, is the ratio of elastic stress to strain. Is the ratio of elastic stress to strain. Now, what does it mean? It means that E, are you getting it? Is equal to, now ratio in mathematics is the same thing as division, dividing, right? So E, which is Young modulus, is equal to what? Stress, elastic stress, all over strain. Now note that Young modulus is a property of a material. Now you should know that the Young modulus of this material might be different from another elastic material. Are you getting it? Now, what does it mean? This is the first formula to know in Young modulus. Stress over strain. Make sure you write it down because we are about to derive another thing from here. What is stress? If I take a rubber like this, the surface, this area here, for example, this, I'm talking about this, I'm not referring to the area of the body, I'm referring to this area, this side. Are you getting it? This side. This area here is called cross-sectional area. It's called what? Cross-sectional area. That is the area we are focused on. We are focusing on. Then the force that extends this rubber, if it is called F, if the force is called F applied to this, it means that stress is equal to what? Force all over cross-sectional area. It's like pressure. The formula for stress is what? Force over what? This force applied over this cross-sectional area. Are you getting it? Now, what is strain? Strain is very easy. Strain, are you getting it? So you can signify it as F over A. Strain is called extension. Strain is defined as the extension per unit length. So the original length of the material is the length here we are talking about. How much the material extended when the force was applied is this extension, and it is this designated as E all over F. Are you getting it? Now, make sure you write this down. Now, if we plug everything here back to this formula, are you getting it? We plug everything here back to this formula. It therefore means that E is equal to, now stress is what? F over A. Stress, which is F over A, all over, yes, all over extension per unit length, E over what? L, right? This looks like a fraction. Let us simplify it. This becomes something like F over A divided by E over L. Now, if we turn it upside down to change it to multiplication, it therefore means that E is equal to what? F over A times L over E. That is become F times L is what? FL. A times A is what? AE. So it therefore means that Young modulus, are you getting it? It therefore means that the other formula for Young modulus, hope you are seeing that part very carefully. Okay, so it therefore means that the other formula for Young modulus E is equal to what? FL over AE. Formula 2. So please, I think we are back. We are at the end of this class. I told you we'll cover everything. Make sure you like, share, and subscribe. Now, if you have problem in memorizing this formula, just know the formula for stress and formula for strain. When time of exam comes, you can just do direct substitution fast and get the answer. Please make sure you share this video and like and subscribe. God bless you all. I wish you success in your exam. Thank you. So in our next class, we'll be using this concept to solve exam problem. Thank you very much. God bless you.